Let me just try. Let me just try the conversation. Right. So let's take DNS for example. Can I remove this? Right. DNS, for example, is a protocol. Let's take DNS. As a protocol itself, how does it work? Basically, you have your PC here, you have a server. So this is your PC, you have a server, a DNS here. When your PC wants to communicate with, let's say you want to Google something, you want to type at www.google.com on your PC. But kuti tisvike kuserver rinotorwa information yeGoogle yacho, tinofanira kunge tichiziva the IP address. What is the IP address? Now, DNS protocol, the rule DNS rinotaura kuti ukaisa domain name rinorequesta kuserver kuti ndine domain name rakanzi google.com, ndipewo IP address. What is the IP address? Server roresponda kuti IP address yako is 10.0.0.1. That's the IP address. Now kana ndaudawo kutsvaga information yangu ndakushandisa this IP address kunotora information. So DNS as a protocol, maaro ari apa, this exchange ndo protocol racho. That's the rule. Kuti nina I have this, I want this. That's a protocol. Understand my protocol from that perspective. It is just communication rule for communication. I'll give another simple example. Yeah, ARP. Protocol runs ARP. I think those are the simplest protocols to explain. Address resolution protocol, ARP. You have a PC here. You have another PC here. All right, let's say there's a switch there. Let's put a router instead. All right, we have these two devices, PC1 and PC2. Address resolution protocol, probably you are trying to connect to PC2 from PC1. And you have the IP address. If you're connecting with a remote network, this PC2 is remote. It's not in the same network with PC1. Right, ARP protocol, what does it say? PC1 inotaura kuti I have this IP address 192.168.10.10. I have this IP address, ndokwandoda kusenda information yangu. But kuti ndisendere information ikoko exactly, I'll need the MAC address, but MAC address handina. Chandinacho IP address. That's very common, because if you understand the idea of my addresses, it's very rare kuti unoziva the MAC address of the destination device yako, but you might know the IP address. But to send information, you need the MAC address so that unokwanisa kusenda to the specific device raunokwanisa kusendera. So how do you then know? Does a device know? So device PC1 parinosenda information yayo yasvika parouter panapa, router yaprocessa information kuti iri kufanira kuenda ku this IP address, which is the IP address of PC2. Router interface ndo rinozorequesta using the ARP protocol kuti nina I have this IP address 192.168.10.10, but I don't have the MAC address. Muridzi we-IP address ndiani? So a message is sent if we have many PCs kunoko. A message is sent as a broadcast to every PC in the network kuti muridzi we-IP address ndiani. Then muridzi we-IP address PC2 will respond kuti IP address ndeyangu and MAC address yangu ndeipi. Overresponda neMAC address yake. Panoresponda neMAC address, PC switch router rakuziva kuti MAC address ichi. Now it can encapsulate a frame redestined to that MAC address. ARP as a protocol just exchange yekuti inini ndine IP address ndikuda MAC address, ane MAC address ane IP address iyi ndiani nganipawo MAC address. That exchange, that's a protocol. So understand my protocols ese in that regard. So every protocol raunoona HTTP panosendwa ma-request, panosendwa ma-acknowledgements, ma-protocols routing panosendwa ma-hello packets, panosendwa ma-DSB packets, ma-database packets, ma-link state updates. is just information, it's just exchange kuti ini ndikuda chakati, iwo unoda chakati, ini ndikuda chakati, ini ndikuda chakati, until network we can finally send something. So that's the definition of protocol, and that should be the foundation understanding yes protocol in. Right. Communication fundamentals. So 3 elements of communication: source, destination, channel. Not much to discuss here. This is my source, this is my destination, this is my channel. When you talk of the channel, is the medium or not transmit information yedu. Different types of mediums that are discussed by chapter 4, physical layer. Fiber, wireless, Ethernet, copper, let's just say copper, different types of media. And one my channels, Ash. And this is my transmitter, this is my receiver, this is my source, this is my receiver. Communication fundamentals, protocols. All communication is governed by protocols. Protocols are rules that communication should follow. Rule establishment. Example yema rules. We have 2 more passages at Panap. Humans' communication between govern rules. It is very difficult to understand messages that are not correctly formatted. Right? If you look at message it's not correctly formatted. I know Tangane capital letter panapa, the grammar is not okay because Munaganyora, this first thing was not following my rules of communication. My rules edo English. Unesa ma full stop, punctuation, unesa ma space, paradigm ma space, etc. etc. Those are rules. Unkatasa, in my proper rules, therefore I can read it easily. It's the same thing in communication. So I think this is just an analog which was being used to show you there is need to be rules when we are communicating, us as humans as well as networks. Right, rule establishment. Protocols account for an identified sender, receiver, common language, grammar, speed, confirmation, or acknowledgement. Right, so protocols in communication, it identifies with sender and yan. The moment you're not 192.168.10.10, this is the destination address. Not 192.168.20.10. This is the source address. I have identified the source and the destination using IP. IP is a protocol, internet protocol. So protocols identify could I send a message in Diane or I receive a message in Diane. In this example, we have the layer 3 protocol. Protocols identify the language or the grammar. When you talk of language, let's say the type of, if I look at the medium, can I fiber? Language and let's say it's light. I send using light. Can I copper? Ethernet. Language and probably I send signal around using my voltages, electrical voltages. So if I have transmission side, don't send a light, the chance language a light, receiving end, kune receiver ne ma voltages. It will be very difficult to understand each other, but communication, right? So we need a common language, common transmission type being used, etc., etc. So instead of having light voltage, we can have sort of a translator here per language yedu. So we can have a module that knows no translator light into voltages, then receiver radio roshanda zanganaka. I think boys in background in telecommunications understand exactly what I'm talking of. Speed and timing of delivery. We have my protocols, a flow control, which controls data rates. Flow control, protocols which controls data rates. Let's say, for example, PC1 and PC2 are communicating. I have PC1, I have PC2 here. I have a switch here, or let's just say direct communication. Right. Interface ripanapa senda 1 gig per second, 1 gigabyte per second. Interface ripanapa can only take probably, let's say, 10 megabytes per second. If information is not, rate of transmission is not controlled, if PC1 pushes 1 gigabyte per second and PC2 can only take in 10 megabytes per second, if rate of flow is not controlled, panongoitika congestion panapa. congestion because data rate riri kutorwa neinterface is very low as compared neriri kupushwa neinterface rekuPC1, right? So there is need to be flow control. So flow control, if there is a protocol ripanapa flow control, probably there's something here which allows only 10 megabytes to pass, so that PC2 can only take in 10 megabytes instead of gigabyte riri kupushwa kuno. And that flow control allows kuti pasete congestion mumanetworks or information packets or frames asadropwe. Packets or frames akadropwa, then we don't have communication. So speed and timing of delivery, confirmation, acknowledgement of requirements. PC1 ikasenda kuPC2, PC2 inoresponda kuti message yasvika. That is acknowledging kuti message yasvika. Otherwise, how do we know kuti message yasvika? That's a protocol which does that. If you're familiar with your protocols, we have, for example, TCP protocol and acknowledgements. Kuti ndasenda information, an acknowledgement is sent back with our message yasvika. Otherwise, if that message is not sent back, how do you know kuti message yasvika if it's not acknowledged? So it's protocols doing everything like that. Protocols all over the place. Network protocols. Right, my protocols, we have my type of my protocols. Let me see. We have network protocols. Okay, network protocol requirements. It's not here. Message encoding, message formatting, message size, message timing, message delivery. My protocols edu, they allow us to determine what type of encoding are we going to use, what type of formatting, what type of encapsulation, message size, message timing. This is related to the flow control. Message delivery options. Uri kusenda kunani? Vanhu vangani vari kusendera, ma-devices mangani vari kusendera. If you are sending to one device, we have unicast. If you are sending to a number of devices, we have multicast. If you are sending to all devices, you have broadcast. So there are protocols which allow us to determine kana ndiri kusenda unicast ndosenda IP address inenge yakaita sei. Kana iri broadcast, it's very easy to identify kana iri broadcast. Kana iri unicast inenge yakaita sei. Kana ndiri kutaura nezve-IP version 6, kana ndiri broadcast or kana ndiri multicast, IP address yacho inenge yakaita sei. So we have protocols which allows us to do all that. Right? Message encoding, converting information into another acceptable form for transmission. So when you talk of message encoding, we have, let me put it this way, decoding reverses. What's the easiest way to explain message encoding? Right. Message encoding, if you look at PC in an image, let's say in a picture, it does send what to this PC. Picture inosendwa in format EP. If your telecommunications is proper, you know that this image, panoita process here, quantization, panoita process, let's just say sampling. Panoita sampling, that image can be changed into 101010101010 into a digital format. That digital format can be changed into more voltages. 5 volts, 0 volts, 5 volts, 0 volts into a signal rakadai. That signal can be transmitted over a channel. Kana rasvika kunoko, that voltage needs to be changed back to this digital format and back to this image. That is encoding. There are protocols which are responsible because which type of format am I going to be using to transmit my message yangu over my medium. Protocols. Message formatting, encapsulation. Let me deal with encapsulation here. If you are sending a letter, rinoiswa envelope. Message yako letter rako tsamba yonyora ingosendwa yakangodaro. Inoiswa envelope, yoiswa address kuti iri kubva kupi, yoiswa address kuti iri kuenda kupi. That is what we call encapsulation. By definition, it'll be a definition encapsulation. It's not there. Encapsulation is basically putting a message in an envelope, addressing it. This is those attenuate as humans can send my letters edu. The same thing happens with my networks. So when a network is sending a message rino encapsulate kwa destination IP address, rino source IP address. Kwa riri kubva nekwariri kuenda. Layer 3, kana tiri layer 2 rinoiswa source ne destination mark kwa riri kubva nekwariri kuenda. That is encapsulation. Rinoiswa muenvelope. Envelope yedu kunetwork, you encounter chinhu chinonzi header, you encounter chinhu chinonzi trailer. Ndo envelope yedu. And in between header and trailer ndo pane message yedu yakavharirwa muheader netrailer. That is encapsulation. So I think we'll deal with encapsulation pamberi a little bit more in detail. What is encapsulation basically? We have protocols which are responsible for encapsulation. Kuti message yedu inofanira kuiswa ma-addresses. There are protocols which define that. Message size. Message inofanira kunge ine size iri proper. Message ikasendwa yakakurisa, it becomes very difficult to receive on the other end. So you see my networks, what they do, they break down a message. Message yakakura kudai, it is broken down, segmented, reduced in size. It is reduced in size so that it can be easily be sent over a channel. Ikasendwa chakangokura kudaro chimessage, it becomes very difficult. Chinofamba very slow, your network become congested, but ikasegment kaita mapiece madiki message, it probably becomes very faster to send it. There are protocols which are responsible for segmentation of that message. After segmentation, probably there is need for sequencing. The 1, 2, 3, 4, 5, 6, 7. I've broken down a very large message, but just send over the transmission channel, probably richashika ku receiving end 7, 5, 6, 1, 2, 3. But this is not the message that I sent. I sent the message 1, 2, 3, 4, 5, 6, 7. But richashika rakadai. Without sequencing, that's a problem. Now kana pane sequencing rasvika rakadai, sequencing irodzosa kuti riite message iri proper. There are protocols which are responsible for sequencing after we've broken down the message kuti size yedu ite proper for transmission. Protocols. Message timing, flow control, nabobata flow control, rate of data transmission. Response timeout manages how a device waits when it does not hear a reply from a destination. Wasend a message, or no reply or message yasvika. If I wait for a time, ndikanzwa kuti haina kusvika, zvikuru kuti haina kusvika, then I have to send again until ndarespond kunzi message yasvika. There are protocols which are responsible for response timeout. Kuti ndikamira for this long, ndisina receive a response, I have to send again because munhu haana receive a message. Access methods determine when someone can send a message. Right. Access methods. I have a switch. Or let's say I have a hub. No. Let's say bus topology. Bus topology, I have my PCs angu. PC1, PC2. This base explains access methods. PC3, PC4. I have bus topology angu. How, if PC1, PC2, PC3, PC4 sends information at the same time, did you share the same medium? But it cannot be collisions. Congestion, you probably understand that better. But it's a collision. It's sort of a congestion. You get my messages, they collide. Then they are not sent properly. Why? Because this is a bus topology. Haina a process, haina a way, haina access methods, bus topology. Let me put it that way. Haina access methods. Determining when someone can send a message. Now, if you look at a switch, it's easy from bus topology, takushandisa switch, PC1, PC2, PC3, PC4. Switch in a way they controller and determining kuti ningi send a message when. Switch, PC1 can send a message, PC2 can send a message, PC3 can send a message, and it will not collide. Because the switch allows my PCs ASAP send a message without them colliding. We have my algorithms. Collision CDMA. Is it CDMA? Collision detection. Okay, let me just say collision detection. We have an algorithm, collision detection. I'm sure you've passed through this. Collision detection, collision avoidance. An algorithm which can be used span up. If PC1 wants to send information, send a message kuti pana arikushandisa medium ere. If nothing responds with Oceansa medium, then it means no one is sending. Then PC1 can send Oceansa medium. If PC2 sends PC1 achisenda, then PC1 responds with Iowa medium irikushandiswa na PC1, then I'll wait, I cannot send. There are algorithms which allows us to have alternate access methods. My algorithms iwayo they develop into my protocols. So there are protocols which allows us to determine kuti arikufanira kusenda information pamedium ndiani, so that we avoid my collisions panetwork yedu. Protocols and protocols and protocols. Delivery options, I've talked of this: unicast, multicast, broadcast. Protocols, right? Network protocol overview, right? My protocol types. We have communication protocols, security, routing, service discovery. Security, very important in network. We have my protocols which ensure data integrity, which ensure authentication, which ensure we have data encryption. With authentication, there's a protocol which allows us to ukasvika panetwork. If you don't identify yourself kuti ndiwani, kuisa username rako nepassword. If you don't do that, ukaisa zviri wrong, you will not be able to access the network. It's a protocol responsible for authentication. My protocols, ese protocols defines everything about the network. Look at data encryption. We have my protocols yekuti data rikapinda rakati ndodosenda information yakanzi Leo. Data encryption inotora message yoyo yobva yaiti EOL. I've encrypted. Message yandodosenda inonzi Leo. Munhu akaona message yakadai so haasvotomboziva kuti pakanyorwa kunzi kudii. This is in simple terms, obviously. That is data encryption. Or inotouya ine something like this: 1011011111. You don't know kuti chasendwa pachii, but in message yangu yandasenda ndangosenda kuti Leo. That data is encrypted. There are protocols responsible for that, for security reasons, so that if an intruder eavesdrops per message yako, they will not be able to see the message yakanzi chii, because they don't know, they don't have the keys. So akashandiswa kuencrypt a message. Protocols everywhere. Routing, OSPF, Open Shortest Path First, my protocols, which are used to determine my path and select my best path network. Right? Service discovery. Discovery protocols. We have my discovery protocols, which discovers kuti my neighbors angu ndiani, my status and my devices wayo ndeapi. So everything in a network ndopa zvinotangira my protocols SA1. Right. Let's go to my protocols acho. Protocol functions: addressing, identifies sender and receiver, IP in a MAC, responsible for addressing. Reliability, provides guaranteed delivery. TCP protocol guarantees delivery because innocent acknowledgements. TCP. Flow control ensures data flow at an efficient rate. Layer number 2, protocol rinonzi MAC, ensures data flows at an efficient rate. Rikasa flow at an efficient rate, so a congestion or my pockets are dropped. Sequencing, TCP, responsible for sequencing. Error detection, wave my protocol is responsible for error detection. Layer 4 arimo, layer 2 arimo, even layer 4 and 2, exactly. Tinema error detection protocols, even layer 7, error detection. Application interface, how process-to-process communication between network applications. Protocols are responsible for all that. Can I finish? Right, protocol interaction. Yeah, let me see. Protocol suites. When we talk of protocol suites, this is just a group of related protocols. You will see we have from protocol suites, group of related protocols. We'll go to my models. I'm going to see my OSI, the TCP IP. So suite is just a group of related protocols. You see from a suite, we'll go to my models, we'll go to OSI, TCP. Here we have 7 layers. The other one, we have 4 layers. And in each of the layers, we have related protocols. In layer number 7 here, OSI, to know the application layer, And in the application layer, there are related protocols which are related to the user interface, how the network interfaces with the user. So basically, a protocol suite is a group of interrelated protocols which leads us to having my models, OSI, TCP, imwe 7, imwe 4. If you look at layer number 7, the application layer, all the protocols are remember they involve interaction with the user because they are related. Evolution, not much to discuss here, but evolution, let me see, TCP, protocol example, protocol suites, communication process. Okay, interesting. Communication process. Protocols are introduced pop up. Okay, let me touch on my protocols as using this communication process right here. Right. My models Edu OSI model is very important. The OSI model, 7 my layers are from the application layer to the physical layer. It's very important to understand them. All right. So it's an application, presentation, session, transport, network, data link, and physical. Right. It's very important to understand 7 my layers are from this perspective. That physical layer is responsible for what per network up to the application layer. Briefly, I know application layer, user interface, presentation, how data is presented, compression, data encryption, those personality about presentation layer. Session layer, initiation of dialogues, initiation of conversations. Don't want conversation in a network, right? The transport layer, segmentation of data delivery, 2 protocols, mainly TCP, UDP. Network, IP addressing, data, MAC addressing, physical layer, everything physical related to the network. Briefly, you need to know what is the function of each layer. Then, Oshipinda Pama protocols. What are the protocols the remote application layer? The common ones, you need to know ana DNS, DHCP, DHCP, HTTP. These are the common ones. As we go from CCNA 1, 2, 3 tichienda, knowledge yako yema-protocols to improve. You need to be very patient. Akawandisa ma-protocols aya. But at least you need to know are very common. Ekuti ukapinda mu-interview ukabvunzwa zve-OSI model, ukabvunzwa application layer, ukasabvunzwa DNS, DHCP kana HTTP, that will be shocking. You need to know those basic. You need to know this application presentation. Again, now TCP is just the application layer. Summarize all my protocols are my application layer. You need to know my protocols are my TCP and UDP. You need to know my protocols are my IP version 4 and version 6. We also have ICMP. We also have my routing protocols are my. You need to know that. My data link layer, you need to know the MAC, the LLC layers. My protocols are my akata sana Ethernet, and point to point, HDPL. You need to know my protocols that belong to that. The physical layer, we also have Ethernet, which belongs to this as a protocol. Waziwa my protocols in each layer, at least 1 or 2. You need to know how they interact. If I'm to send information here, if I'm to send information from this PC up to this server, how are the protocols interacting? Couldn't send a message yangu? And how is data being encapsulated? Right. So let's look at an example that I'm sending information. That best explains how my protocols interact. I want to send information from that PC to a server. Information yangu, let's say I'm sending something on a web page. HTTP, data. Okay, I'm sending something on a web page. Kana ndiri kusenda ndinotangira ndiri kuapplication. That's where the user interacts with the network. I'm on my computer, I'm typing something per web page. I'm interacting with the HTTP in the application layer. Right? I've typed something or I've requested an image. Right? Request yangu starts going down the OSI module until yasvika physical. You need to know the protocol interaction yasvika physical. So briefly, web page rangu request, let's skip my protocols under DNS and all. Let's just talk through layer by layer what is happening. I've requested for a page, or let's say I've sent an image. I've sent an image over the web page. Parinosvika presentation, that image is compressed. Message size, kana ranga rakakurisa, it gets compressed. Tambotaura nezvimwe protocols which involve message size. Security, image rangu rovha raitwa encrypted, data racho rasendwa ma1010 over raitwa encrypted. Tiri mupresentation layer. Topinda musession, a dialogue is initiated with the web server. A dialogue is initiated kuti izvezvi we want to communicate the web server rinori. So dialogue redu ratanga. That is the initiation. Todzika tamtransport, image rangu probably rovha segment kwa message size again, roitwa sequencing, reliable delivery or UDP and reliable delivery depending noti chii yauda kushandisa protocol. Rodzika ropinda munetwork layer, rakuiswa maaddresses kuti riri kuenda kupi, riri kubva kupi. Rodzika ramudata link, roiswa mamwe maaddresses futi emulayer 2, maMAC addresses. Kana tiri kusenda locally, maMAC addresses anoshanda. Kana tiri kusenda remotely, MAC address, IP address takes over. So panapa roiswa source mark, destination mark. Rapinda muphysical, data transmission, ma1010 akupinda muchannel yako, hewo akusendwa, then asvika pa server redu. How many minutes do I have? Right, 1. Asvika pa server redu, anosvikira ari kuphysical. Encapsulation yangatiri kuita tichidzika kudai so, tichiisa maheader nematrailer. Kana takukwidza kudai so, encapsulation, takubvisa maheader nematrailer edu. Tabvisa panapa, mabits edu tabvisa header netrailer, tasvika padata link layer, tatarisa kuona kuti maframe edu, madestination nesource mark akaita sei. Okay, nderedu packet yokwira. Totarisa IP address ndeyedu yokwira. Totarisa maport, masource port patransport layer ndeyedu tokwira. Session yedu, okay, message ndeyedu, toterminate session yangatanga uko tokwira. Presentation, toita decompression message yedu, toita de-encryption message yedu tokwira. Application layer, munhu anga ari kunoku akaona image ranga ratasenda tiri kunoku, tiri kupc number 1. That's how communication happens. You should be able to explain communication in that way. I have 1 minute rasara panapa. I'm going to start another session so that we continue to say this chapter.